Hi everybody, Miss Lorette here again. So I'm going to walk you guys through lesson 6 for section 2.1. We're still solving one-step equations. In this lesson, we're going to focus on equations that require multiplying and dividing, as well as working with fractions and sometimes integers. Okay, so you're going to want something to write with and something to write on, but no calculator this time. Go ahead and copy these examples in your notebook. Pause the video if you need more time to copy them down. And as you can see, these aren't equations. We need to kind of review some things before we work with some equations. So in order to multiply fractions together, a little bit of review here. We actually don't need a common denominator. All you do is you multiply across the tops and multiply across the bottoms and reduce when possible. In math, it's not considered fully simplified if it's not reduced. So you must reduce if it's something that can be reduced. I prefer reducing beforehand. I think it's easier because then you're reducing smaller numbers. And to do that, which we sometimes refer to as cross-canceling, you're looking at the numbers at the top and the bottom and seeing if they can be divided by anything. So 4 and 3, I can't reduce that by anything, but I can reduce both 4 and 10 by 2. So if I divide 4 by 2, I get 2. If I divide 10 by 2, I get 5, and that's as much as I can reduce them. 3 and 1 won't reduce any further, so now I can simply multiply and my answer will be completely reduced. A positive times a negative will give me a negative. 2 times 1 gives me 2. 3 times 5 gives me 15. That's my final answer. For ones like number 2, if you have an integer involved, I think the easiest way to do this is to simply rewrite that integer like a fraction. So take the -6 and simply put it over a 1. You can do this with any integer. You can always put an integer over 1 to make it look like a fraction. And then I'm just going to copy the other fraction. And now I can look for things to reduce. So I can't reduce 3 and 1 again, but I can reduce 4 and 6. The biggest number that I divide evenly into both is 2 again. 6 divided by 2 gives me 3. 4 divided by 2 gives me 2. And now I multiply across the tops and bottoms. Negative times negative is going to give me a positive fraction. I'm just drawing my fraction bar here. 3 times 3 will give me 9. And 1 times 2 gives me 2. And again, it's a positive fraction because the negatives canceled. Okay, so let's take a look at some division examples. Dividing fractions is very similar to multiplying. There's just a small adjustment that we need to make at the start. Some of your teachers might have referred to this as keep, change, flip. All you do is you take this first fraction and you leave it the same. You change the divide to multiply, and then you write this second fraction as its reciprocal. So in a previous lesson, we actually defined that the reciprocal is kind of like turning a number upside down. So the numerator and the denominator are simply going to swap places. And now we multiply like before. So again, I like to look for things to cross-cancel before I multiply. 5 and 1 won't reduce, but I can simplify 12 and 14. I can reduce them both by 2. So that'll give me 6 if I divide 12 by 2, and that'll give me 7 if I divide 14 by 2. And now I just multiply like before. 1 times 6 gives me 6. 7 times 5 gives me 35. And there's my final answer. Let's try this one over here. I'm going to keep that first fraction the same. I'm going to change the division to a multiply, and I'm going to flip that second fraction upside down. So it's going to be 10 over -13. And now I'm going to look for things to cross-cancel. I can't reduce 4 and 13. There's nothing that'll divide evenly into both of them, but I can divide 5 and 10 by 5. If I divide 5 by 5, I get 1. If I divide 10 by 5, I get 2. And now that everything's cross-canceled and reduced, I can simply multiply. -4 times 2 gives me -8. 1 times -13 gives me -13. Lastly, the two negatives will actually cancel out and I'll get a positive. Okay, let's take a look at some equations now. Okay, so again, you might want to, whoops, that's a little messy. You might want to draw a line down your equal sign if that's a nice visual for you, but you don't have to. So here I have a fraction touching a variable. That means multiplication. We know that the inverse is to divide. So I would actually have to divide both sides by 1/2. But we also just reviewed that dividing fractions, you do keep change flip. You end up multiplying by the reciprocal. So instead of dividing both sides by 1/2, I'm just going to skip that step and multiply both sides by the reciprocal of the fraction that's touching the variable. What ends up happening is that these 2's cross reduce and the 1's cross reduce. So everything cancels out here and I'm just left with my variable. But what I do to one side, I must do to the other. So I'm going to look for things that can cross reduce here. 17 and 1 can't reduce, but I can reduce 2 and 8. I can divide them both by 2. The 2 turns into a 1. The 8 turns into a 4. And then as my final answer, I simply multiply. Let me actually move my answer a little bit further down so I've got some more space. So n is going to equal 17 times 1 gives me 17 in my numerator. 4 times 1 gives me 4. There's my final answer. Okay, so you might see an equation that kind of looks like this, where instead of the numerator being off to the side, like in the first example, it's actually with a number sitting in the numerator. It means the same thing. You're going to look at this 3 and 5 as if it's a 3/5. To get the variable alone, whoops. Hard for me to draw straight lines with these tablets. In order to get the n alone, I know I'm going to need to divide by 3/5, but that's going to end up turning into, because of keep, change, flip, into multiplying by the reciprocal of this fraction. So I'm going to do that and just skip the dividing step. I'm going to multiply both sides by 5/3. I'll do it over here too, because what I do to one side, I must do to the other. These 5's on the left are going to cross cancel, and the 3's are going to cross cancel. Everything's going to cross cancel, leaving you with just your variable. I'm going to bring my variable down as well as my equal sign. And on the right-hand side, again, I'm going to look for things that can cross cancel, because if I don't, then I'm going to have to reduce at the end. And 27 times 5 is probably going to give me a bigger number that's going to be a lot harder to reduce. So I'm going to reduce first. So I can reduce 3 and 27 both by 3. The 3 will turn into a 1, and the 27 will turn into a 9. 5 and 40 can also reduce. The 5 will turn into a 1. I can divide each of these by 5. And the 40 will turn into an 8. Okay, and now that I've reduced everything, I multiply. 9 times 1 gives me 9. 8 times 1 gives me 8, and it's fully reduced. That's a lot easier, in my opinion, than doing 27 times 5, getting a product, 40 times 3, and getting a product, and then trying to reduce those really big numbers. Whoops. Okay, so let's take a look at these two examples. So as we can see, we've got a mixture of different types of numbers. I've got a fraction and I've got an integer. So let's take a look at the equation on the left side. So here I have an integer. But because I know I'm going to have to deal with this fraction, it might be easier to put this integer over a 1 and make it look like a fraction. So now when I solve this equation, instead of dividing by -2, because again, with a fraction, I'm going to have to do keep, change, flip, I'm just going to multiply by the reciprocal of that fraction, which is 1 over -2. And I'm going to do that to both sides. The 2's will cancel, the negatives will cancel, and the 1's will cancel. Everything will cross cancel here, leaving me with my variable. And on the other side, I'm going to look for things that can cross cancel. The 1 and 3 can't cross cancel, but the 2 and the 28 can. 2 can go into all even numbers. So I can divide these by 2. 2 divided by 2 gives me 1. 28 divided by 2 gives me 14. We're just cutting 28 in half. The two negatives are going to cancel, leaving me with a positive when I multiply. My numerator, 1 times 14, gives me 14. 1 times 3 gives me 3, and there's my final answer. Again, you can write it as a mixed number, but you don't have to waste the time doing it. And let's take a look at this next example. Now my integer is on the other side and I have a fraction near the variable. Again, it might be a good idea to just make that integer look like a fraction because we're going to have to be multiplying it with a fraction. So again, I could divide both sides by 5/2, but I'm going to have to do keep, change, flip, and change it to multiplication anyways. So I'm going to skip that step and just multiply by the reciprocal of the fraction that I see. And I'm going to do it to both sides. The 2's will cross cancel, the 5's will cross cancel, and I'm only left with n on the right-hand side. And now I'll look for things to cross cancel on the left. The 2 and the 1 can't reduce, but I can reduce 5 and 5. I can divide them both by 5 and get 1's. A positive times a negative will give me a negative answer. 2 times 1 gives me a numerator of 2, and 1 times 1 gives me a numerator of 1. Now I can leave my answer like this, but some of you might have noticed that any number divided by 1 is just itself. So I could also write my answer, like this. 2 over 1 is the same thing as 2. So either of these would work. Okay, so now I'm going to pause the video and I'm going to let you guys try these on your own. Try all 4 of them, okay? And then when you're ready to reveal the solutions, unpause the video and the solutions will be on the screen. Okay, so here are the solutions that you should have gotten after doing these problems out. So for the first one, you should have multiplied both sides by 8 over 9. The 9 cross cancels with the 27. You can divide both of them by 9. The 9 turns into a 1, 27 turns into a 3. And then the 8 and the 16 also reduced by 8. 8 turns into 1, 16 turns into 2. And then you should have gotten negative 3/2. The next one, you should have multiplied both sides by 10 over 9. The 4 and the 10 can reduce by 2. 4 turns into 2, 10 turns into 5, and the 9's both cross cancel with each other, both turning into 1's. You should get positive 5/2 as your answer. The next one, I made the 2 an integer by putting it over 1 and then multiplied by 1 over 2. Nothing cross canceled here, so I just got negative 9 over 8. You might be looking at the 2 and the 4 and thinking, why didn't those reduce by 2? That's because they're across from each other horizontally side by side. In order for numbers to cross reduce, they have to be across from each other, top and bottom, vertically, okay? And then the last one, I made the negative 4 a fraction by putting it over 1 and then multiplied both sides by negative 3/2. The 4 and the 2 can reduce by 2. 2 turns into 1, 4 turns into 2, and the 2 negatives cancel, leaving you with a positive 6 over 1 or just 6, depending on how you want to write it. And that's pretty much it. I hope you guys found this lesson helpful. Of course, if you have any questions, reach out to your math teacher. And feel free to rewatch this video if you need any clarification. See you guys next time. Bye.